The processing speeds of 10 new laptops in an office are found to be 3.2, 2.9, 3.0, and so on. So here, when they say 10 new laptops, this is your sample size. So n equals 10. And here what you have are your individual observations. So these are your x values. This will be x1, x2, x3, and so on. And your last value will be xn. Now here's the real question. Is it reasonable to believe that the mean processing speed is lesser than 3.0 gigahertz? This is the part you need to focus on. Lesser than 3.0. Here 3.0 will be your mu0. And this will tell you what your alternate hypothesis will be. So lesser than means your H1 will be mu less than 3.0. Here instead of 3.0 we'll put this symbol. And the last part of the question is test at 5% level of significance. So 5% is your alpha value. So far we have alpha, n, and mu0. So these are your hypotheses. So here H0 is your null hypothesis and H1 is your alternate hypothesis. Alternate is the one that you get in your question. Now look at the symbol here. If it's less than, then it means that it's a left tail test. Remember this, we'll need it later when we're finding the critical value. Now let's move on to the next part. Now we need to find the test statistic. So this is the formula. Here x bar is your sample mean. Mu0, we saw that earlier, it's your population mean. S is your sample SD, which is standard deviation. And N is the sample size. So we use S when we don't have your population standard deviation. So for our tutorials, I think we don't have many questions where they've given this. So for us, everything is usually S or some variation of it. So let's solve this now. Here mu0 we already got from the question, n also we have from the question. So here what we don't have is your x bar. X bar is the average of your sample observations. So to find this, you just add all your observations and divide it by 10, which is also your number of observations. So here you'll get it as 3.1. Now that you have x bar, the only thing missing is your S value. So this is the formula to find S. So first let's find sigma xi to the power 2. Here you just have to find the square of each of your observations and then add them. Here you'll get 9.61. So now that we have that, the next thing we need to find is x bar square. So we already know what x bar is. We found that previously. So just square it and you get 9.61. So now we just need to substitute these values into this. I would suggest that you just directly do this in your calculator. It will give you more accurate decimal values. So you can write this as open bracket 96.4 divided by 10 close bracket minus 9.61. So if you do this in your scientific calculator, you'll get your final answer directly. So now that we have S, we can apply it to our T formula. And here again, I would say you can use this part directly in your calculator. So it would be 0.1 divided by open bracket 0.1732 divided by square root of 9. And that will give you this. Now we need to find the critical value. So here we already know what alpha is, and n minus 1 is 10 minus 1, which is 9. So for this we need to use a t-test table. So here 9 is your degrees of freedom and 0.05 is your alpha value. So here find 9, and here under one tail find 0.05, and whichever value where both row and column intersect is your value for T alpha n minus 1. Now if this was a right tail test, this would have been your critical value, but since it's left tailed, we have to make it negative. So your critical value for this question will be negative 1.833. So now the next step is to compare this with this. So this is the diagram for T distribution. Here this line represents your critical value, which is minus 1.833. We just found that earlier. And now we need to find where your T calculated value here, which is 1.732, is in this diagram. If it's on the rejection side, we reject your null hypothesis, which is H0. If it's on this side, we don't reject it. So let's say 0 will lie somewhere in the middle. So 1.732 will be somewhere around here approximately. For this question, your answer is we do not reject H0, which is your null hypothesis. And you can conclude that there is no reasonable evidence to believe that the mean processing speed is less than 3.0 gigahertz. And that's it.